Hello guys, so today we are back with another DSA question. This time we are going to be seeing the longest substring without any repeating character. Alright, so what does it mean? You'll be given a string, let's say ABC, this particular string, alright? And you have to find the length of the longest substring so that there's no duplicate character in that. So for example, you could choose ABC or you could choose BCA or any other such string. In this case, the longest length will be 3. In this particular case, the longest length will also be 3. You can see that if you do WKE, that length is 3. Or you could also do KEW, the length will still be 3, right? So let's discuss the approach to solve it, and then we will see the implementation in Python. We will take the last example from the question as as the one for our explanation. So let's say it is PWWKEW. The way we are going to start is we will start from the left hand side and we will keep that as our starting index, and we will keep moving forward one index at a time. Anytime that we find a character that has already occurred, we will update the length of our longest string if it is indeed more than the previous substring. So I know that sounds like a lot. Let's just introduce the variables that we will have and we'll see how to update them. First up, we have got a master lookup table, which is basically a hash map that tells you which indices have already occurred, which characters have already occurred and at what indices. The reason this is a hash map is so that the lookup can be completed in order one time. Hashing is a fast technique, and I'll make a video on it in future about how it internally works. Start is where start at any point in time will tell us where does our current substring start from. Initially we will start from the leftmost one, so we'll initialize start to 0. And lookup table is initially initialized to just an empty map or an empty dictionary in Python. And then comes the high, right? High is the length of the current longest substring. Cool. Right now there is no substring, so the high is also 0. Right, so this is the algorithm. We start from the start, which means right now 0, and we see the character that is present. The character is P. Is it there in a lookup table? It's not. So let's go and add it. We add the key P, and for the value, we add the index of P, which is 0. Cool. Lookup is meant to store the last known index of any particular character, all right, that we have encountered. Cool. So let's move forward then. Next item. Start won't change, all right? Start will only change when we find a duplicate. Start is still at 0. All right, so the index now is W, is at W. Now is W present in a lookup table? It is not. So let's go ahead and add that. W and add the index 1. Right, then we go to the next index, I is equal to 2, and it's a W again. Now comes the interesting part, right? Because W is already present in our lookup table, it means we can actually no longer start our substring from 0, as you know it will always contain duplicates. If a substring starts from here and keeps going forward, this WW will always serve as duplicate. So what we're going to do is, it's quite clear that our start now needs to be updated. All right, start definitely has to get updated. Cool. So what we'll do then is let's introduce some variable called as index, which is, or like the L index, the last index. This is the last index of the current character. What was it? It was 1. So let's say, all right, L index was 1. This was where the string last occurred. Now, is the L index to the right of start, right, or equal to start? It is. So in that case, what we will go ahead, what we will do is we have to now update the value of start index. All right. So start will become equal to L index plus 1. Previously, W occurred at 1. So now start will become at 2. Why do we do that? Because if you start from anywhere at L index, which is 1, or to its left, you will always have this WW as a repetition. So the most logical place to start for a new substring is at the last index of the duplicate item plus 1. Okay? So this is where you do the start from. And now you have to see if high needs to be updated. Cool. So what will be the value of high? Okay. What was your start? Now you have actually already updated the start. So ideally what we'll do is we'll update the start later. For this iteration I have shown, but we'll actually update high first and we'll update start later. All right. So start right now, let me actually just do that. Yeah, we know that start has to be incremented, but we'll do it after we have updated high. All right. So first we will check, okay, what is the value of new high? All right. High will be the current index I minus the start, which means PW. So the high will basically be stored at 2. Start will now become the last known index, which was 1 plus 1. So start is now here. Cool. Start is no longer at 0, start is at 2. And without a doubt, you have to update the value of W in your lookup table as well. Alright. Then let's go to K. When you see K, you see that K is not present in the lookup table. So let's just go ahead and add K at index 3. By similar reasoning, E will come at index 4. And then you find a W again at index 5. Cool. No worries, let's just begin our process again. So we'll find out the last known index of W. It was 2, right? Cool. So that means our new start should now become 2 plus 1, which is 3. But as we said, we will first update high and then update start. So what is the value of high? All right. That means that, okay, the value of the current substring starts from 0, sorry, not 0, 2, and goes all the way till 4, 4 included. So that means all the way till 5 excluded. So the length of high right now is 3. That means you should update that. Update 3. Then you should update the start as well to L index plus 1. Last index of W was at, remember, 2. So 2 plus 1 is 3. That means your new index now begins at index 3, right? And you have to update W here as well at index 5. Now you have exhausted the entire string and there's no more character, right? So does it mean that the high is the answer that we should return? Maybe, may not be, not necessarily, all right? This high is basically the highest substring before this current value of start. So it could happen that the last continuous value is the biggest substring. If you had something like a T and N over here, you will actually not be updating high to 5, but towards the end you will have a high substring of 5, right? So what you need to eventually return is either the high or length minus start. All right. As you can see here, length is 6 and the start value eventually is 3, right? Start actually got updated to 3. So high comma length minus start. Whichever one is the highest value among them, that is what you have to return. Cool. So now we will go ahead and implement this code in Python, and we will also keep coming back to this slide. Let's just open it side by side here. All right. Okay. It's a tough time to resize this. Cool. So let's say this is what we have. Right. We create a def longest. Let's just say longest without repeat. All right. And there's a string s. So first up, what we have to do is we have to initialize these variables, start, high, and lookup. All right. So the default value of start is 0. That's where we are starting from. The default value of high is 0 because that is the initial length. And lookup initially is just an empty dictionary, right? Cool. Now we have to go over the entire string character by character. So we say for I in range of len of s, we will get the character stored at that particular index. So let's just introduce a variable char. Char is equal to s at I, right? And we need to have our check if this character is present in the lookup or not. So if char is present in lookup, then in that case, what do we need to do? If it is present, then we need to get the last index of it, right? So we'll just call it L index. L index is equal to lookup at char, and we need to see if this last index is to the right of start or not. What it means is that, let's say this current index occurred, but it occurred like way back in time, then you don't really need to worry. If it is below the current start, then it doesn't really affect us. So if L index, if that is more than or equal to start, only in that case we need to make some updates. Otherwise we can just ignore. Okay? So if L index is more than or equal to start, then in that case what can be done is we have to first update the value of high, right? So high is equal to max of high, which was the existing one, or the new value. How will we get the new value? We'll get that from the current index I minus the start, right? And after this you also have to update the start as L index plus 1, right? Once we have done this, we can come out. If L index is to the left of start, then we don't need to do anything. If character is present in lookup, so regardless of whether the character is present in lookup or not present in lookup, we do need to add, right? Now because it is a map, it can't store duplicate keys, right? Therefore this is like an add or update operation. So what we have to do is we have to update lookup at char to the value of I, and that's pretty much it. Eventually, as we discussed, we will return the max of either high or the length of string len of s minus the last known start index. So this is going to be our code. All right, let's just write a few test cases and check it. So let's call print longest wr, and if we print something like AAA, then this should give out 1, right? If we do AABB, that should give out 2. If we do ABCA, that should give out 3. And towards the end, like, okay, one ABCD, probably just one more, which is what we started out with, PWWKEW, right? So the output that we expect is 1, 2, 3, 4, 3. 1, 2, 3, 4, 3 should be our answer. All right, let's just go ahead and run this. 1, 2, 3, 4, 3. So as you can see that this is the longest substring without repeating code written in Python. Alright, and thank you for watching this video. I will also be making a video in Hindi and share the link of it in the description. Also the link for this code will be available in the description. Thank you guys for watching this.